Yes, I've just got a project going at the moment where there's a tall tree adjacent to a second property and my property, which is being developed. Um, and It's a little bit controversial, shall I say. And I don't know what's happened to the development next door to it, for example.
Mhm.
So I'm in a situation where I'm going to say, okay, this complies with the Australian standard. The amount of encroachment complies, but I don't know what happened on the adjacent property. And My feeling is, well, I'm going to put in the report that this tree should be inspected by a qualified arborist every 2 years or something, for something like that, and try to cover the situation. But um,
That's sufficient, Rob. And if you did that after the 2 years that expired, the second inspection should pick that up. So you're limiting the period of your exposure to a negligence claim. Remember, it's only negligence. And in the case of Turner, there's some things that he did that were rather silly. You know, he identified some trees that he said all of a sudden had an accelerated or higher risk. We don't sort of get to know why. It's a little bit strange that he's done that. One of those drops a branch, it hits a person. Again, odds are getting fairly small. That probably covers, 20 or 25 incidents a year in Australia. So still a very,
yeah,
and still arguable that that's a reasonable thing to leave as a tree in that situation. So
But
that,
but the key thing was, Mark, that he said that the trees were, in inverted commas, dangerous, and then didn't do anything.
that's right. He didn't give any specifications and any timelines. Um,
mm,
so, that was reasonably negligent. Most of us nowadays wouldn't make those mistakes because most of us have learnt from the mistakes of those that have gone before us. Having said that, the whole role of the legal fraternity is to try and show that you are incompetent and that you are negligent, that you are stupid, that you don't know anything, all those sort of things. So there's a point to which we have that indemnity insurance there to cover us, um, for
Um,
not so much for the mistakes we make, but to deal with those issues. And I'd add further, if you're a corporate structure, that is, if you've got a company structure, then you're limited to the value of the shareholdings in any case. And so for some of you that run smooth and neat little businesses, there probably won't be too much value in the company either. So you can doubly limit in those ways. Um, in Turner's case, he was a sole trader, and the insurance had been allowed to lapse. So had his insurance continued, he would have been covered against that negligence, and that's that whole thing. But I don't know what I spend, Peter, on professional indemnity, but I'm thinking it's somewhere around about 1,500 to 2,500 a year or something like that. It's not a huge amount at all, and that's for $20 million. So um, you know, we're not talking, the running on for the next 5 years might cost you that in total. And if that's all of the cost, then for the peace of mind for your estate, um, or for you having stopped working, I think that's probably worth paying that.
yeah. Thanks, Mark.
No worries. Well, let me share my screen. And first of all, we'll look at the images that have been sent. And thanks again for those that send images. They really do make the process a lot easier. I'll start with Vicky's. Vicky, you online?
Yes, I'm here.
Great. Just wanted to make sure. So this is looks like a Crimbia maculata, might be a
It
variegated.
is.
Yeah, okay, good. So first thing we've got is a basal wound, and we know some things about macular, and that one of the things we know about it is it's fairly durable as a timber. So, and that has some bearing in this instance because we've got timber exposed, we've got wood, dead xylem exposed, and a basal wound that looks like about maybe 25 to 30% of the circumference of the tree at this stage. It may have been bigger than that um, when the wound was back here, woundwood was back here, and the tree was a little bit smaller in diameter. Um, Eventually, all things going well, these two will meet up and we'll end up with the tree grafting together. And Crimbia maculata in particular is really efficient at producing woundwood. So it may well completely occlude, and you'll just have an old seam and some small amounts of evidence that there's been an injury. But apart from that, it's a telegraph pole on the inside with a live tree on the outside. And oftentimes we think of trees as approaching a safe margin that's sort of 4 to 1 to 1, 4.5 to 1. But frequently trees provide a lot greater safety margin than that. And it's hard to tell, but it looks like the tree might be 60, 65 centimeters in diameter, something like that.
Yeah, yep.
Yeah, so it's getting close to being a big tree. And the trees that are more likely to fail with loss of strength are young, fast-growing trees. And you think about it, the young, fast-growing tree, primary goal is to get canopy and get light. Once they start to get a thicker trunk, the whole behavior starts to change. And so I would look at something like this and say, well, it's unfortunate, it's happened. Take good care of the tree, maybe remove some stuff from around it or put some mulch down. You know, if you want to put the bin there and use it as a storage area, maybe put some load sharing surface down, maybe concrete or some pavers, something like that, preferably without too much digging. Although, again, when you get a little further away from the base of the tree, you're likely to find those larger woody roots are down, you know, maybe 10 or 15 centimeters already, in which case just cutting a slab into grade a little bit is probably not so bad. So that's how I feel about it, without being able to see anything more. I don't get worried about wounds on trees. Most trees, that's not a problem.
Okay.
Yeah.
Maculata is used a lot as a rootstock, isn't it, for grafting?
Yeah, it's on the East Coast because when we're grafting Physifolia, it takes graft fairly well. Maculata and Variegata, we had a lot of rejections. So we did a variegated one onto Maculata rootstock. We had Tony Hoopman do them for us, and huge amounts of rejection. Citriodora was a lot better.
Okay.
And Citriodora onto Citriodora, but Maculata onto, or Variegata onto Maculata, we had probably 75% rejected.
Oh, okay. So yeah, I dug one out. It was terribly difficult. So maybe it was on Citriodora.
I imagine Maculata. I mean, you know, they're great trees. We often think of, you know, trees as being problematic because we see them failing. But when you start looking at what you've got to do to get trees that don't fail out, there's a huge amount of effort involved in doing it. And even sometimes when they've started to have movement in the ground, they can still be hard to get out.
Yeah, it was the hardest one I've ever dug out, actually.
Yeah.
The tree died. The Phycofolia had died. Yeah.
So now this one here has been sent by Nisse. Is Nisse there?
Yeah, yep.
Yeah, excellent, great, nice to be able to talk about things. Okay, well, the first thing that threw me off here is this picture, and I'll see if I can make it a little larger for you guys, hopefully, is a viminalis with a split trunk.
Yep.
And the first thing that threw me out is that this doesn't look like viminalis to me. And so again, I'm only a novice at arboriculture, so I had to hop online and start having a look at a key and realize that indeed there are 5 subspecies of viminalis.
Correct.
Occur in Victoria, and both the 2 that occur in Victoria have rough trunks. In particular, Amprioriana, almost all the way to the top, rather than shedding in ribbons, which really threw me completely. Because we've
got a few. That's on my my in-laws' property, and there's a few of them there. I think it's the not Periana, the other one. What's it called? Signatensis or something like that.
Yeah,
possibly.
And
I think that's the one. They're actually native here.
Yeah. So, and this is why it's important to know something about trees and where they come from, and we'll talk about that during the course of today. So yes, in terms of doing things, we've got a co-dominant stem that has split, and we now call this, thanks to the layman's trick case, we now call this a partial failure. We don't say that the tree has failed. we say it's partially failed. There looks like there's been a limb that's been cut or broken here, and there may have been an old failure up here. Is that correct?
I think that cut is probably just someone with a pole saw. But up to, yeah, sorry, it's a pretty bad picture, but up the top there, it's all good still. There's no tear outs or anything.
Right. So what would you do?
What's funny as well, we just had a massive localized storm on that property, and there's trees down everywhere, but this one's still standing.
No, that's not at all surprising. You know, we have this phobia, and they can fail at this. Don't take me the wrong way. But you can also see trees with co-dominant stems, included bark, split like this, and find it fail further up.
Yeah, yep. There's a few of them around as well.
Yeah. So we don't know how adequate or inadequate this is in terms of strength. That's an unknown quantity, and I don't know of anything at this stage that would allow us to test that. And a part of the reason, you know, that these things exist is they get heavily loaded during a storm, and they get to a certain point and then they stop.
Yeah.
Often associated with a notch in the tree or an old fork or junction that seems to bring them to a halt. And I've seen them stay like that for 40 odd years after the cracker started. So, you know, what do you do? My first thing is it looks fairly new, and I'm always more concerned when it's a new split than when it's not.
Yep.
Going to depend on the target. So
yeah, there's really no targets.
No target, so we can let the tree fail if the tree is valuable. Let's say that this has some sentimental value or makes the vista look fantastic. Then we could do some bracing, so some rods through. And how big a trunk are we talking about here? Is it 600-800 mils?
Yeah, probably closer to 600.
Yeah. So maybe 2 rods offset from each other would be the sort of typical recommendations. Pull them in, tie them in.
Yeah. So bolted together, really.
Yeah. And then potentially if you want some reduction pruning, and reduction pruning significantly reduces the load on the fork. And, you know, there's those that argue for and those that argue against reduction pruning. I think it's got an important role, but follow the Australian standards in terms of what you reduce to. Now, let me share with you. So I've made it clearer. If I can, photos. Now, just trying to think what it would be saved under. Helensburgh is HELENSBURGH, I think. NSW, just in case it wants to find one elsewhere. So whilst it tells me whether there is or isn't one, yeah, there's one. So this is a Eucalyptus botryoides that has been reduced twice. This is a year after the reductions occurred. You know, I'm not offended by it. It's not the sort of thing that I'd preferentially choose, but in this case, there's a very distinct reason for this, and the distinct reason is there's a proposal to put a platform in the tree, so an area where people can utilize it. And this is a tree owned by an arborist, so he's done a reasonably good job, not me. I wouldn't do a reasonably good job. I'm getting too old for it. But it's a platform that'll be able to take about 10 people in it, so it's quite a reasonable sized platform. And just the amount of reduction pruning has given the tree significant increases in safety margins. So it's gone from, you know, something that had a safety margin of 6 to 1 to something that's got a safety margin of probably close enough to 20 to 1. So just huge increases in strength from that reduction pruning. So a small amount of reduction pruning has huge impacts on load. If you can keep that in mind. And tree calc does go through that and shows you, you know, a lot of things like Botrytis not in there, but I just put it in for Pilularis and something else and said, look, you know, this is comparatively what we're looking at. May not be perfectly aligned, but it'll give you enough idea that the load reduction has just given huge margins. And you know, that's something that we want to do. So back to your tree, if there was some suitable spots that you can come in from the outside, make a few reduction cuts, it doesn't have to be a huge amount. It certainly will reduce the load. The other thing that you can do is put a Cobra system in up higher.
Yeah.
Stop the, in strong winds, the extremities going too far. But, you know, I don't know that's necessary. You know, give it a bolt. If you can get it in fairly close, it'd almost be worth your while scribing close to the edge and doing something really horrible and putting some lanolin on and trying to get woundwood developing and hopefully inosculate. Because once that joins, it wants to join by laying down a veneer, a layer of ply, one over another in opposite directions, and it's incredibly strong.
Yep. That was my next question. Is it gonna sort of seal over if you bolt it together?
Occlude over, yes, and once it starts to occlude over, and Viminitis is a very fast-growing species. From my experience, it's probably not as fast-growing where this is because of little drier conditions.
Yeah, they don't get nowhere near as big as well.
Yeah, but you know, it's not a, you know, tree that's only growing you know, 500 mils a year in terms of height and putting on a you know, half a mil or 5 mils of trunk. It's probably only a 40 or 50-year-old tree, something like that.
Yeah.
And
Mark,
so
would you pull the leaders together to get the brace up tight, or
if you can, Mick, without overdoing it, and just be careful if anything's fallen in there, it can act as a fulcrum point and cause the cracking to generate downwards. So don't do that, and make sure it is clean or relatively clean. You know, if you've got a stick or a rock that's fallen in there, it can act as a pivoting point, like a pair of tongs, and cause the split.
Oh yeah.
But
yeah, that's a good point.
so 2 or 3 rods, or
2 rods would be the normal, slightly offset, pulling in with the highest one being closest to the side that's most split. You know, it's hard to know what sort of size. I'm not an engineer, but you know, something like an M14 or an M16 bolt would probably be more than adequate.
and would there be any efficacy in putting one above the union?
I always worry about bolts above the union. If I'm going to do above the union, I'd rather go to a Cobra system that's got some flexibility rather than something that's rigid. The trunk is meant to be rigid. Up here is meant to be moving. You know, the trunk is meant to be integral within itself. Does that answer your question, Mick?
Yep, thank you.
Good. So, okay, next one. Same one, and this is a Ficus obliqua, and just the fused bud or the Siamese twin that's occurred here. And again, this happens in nature with enough regularity. You get all sorts of things fused together. So here's a bud that's fused, and here's another one on Cisia, Eucalyptus Cisia. Is it Eucalyptus Cisia or Crimbia Cisia?
I don't know, Silver Princess.
Yeah, what it is, Eucalyptus, is it?
In my
recollection,
knowledge, yeah. But
Yeah.
this one's got
I think it's still eucalyptus.
yeah. I wasn't sure whether it was a Crimbia or not, because it's got a fairly big urn-shaped fruit, which is one of the characteristics. It doesn't have, well, it does have a decorder. It's a, what do they call it, Minorichi bark, don't they? Bark coming off in little curls.
yeah, yep. This one's got almost all the buds and fruit on the whole tree. They all fused.
Yeah, it's
two or 3 or 4. We even got one with 5 on there.
Wow, that's pretty neat. Now this is spectacular, to say the least. This is a acacia, and we've got a gall on the fruit, and again right through the tree. Did you happen to find out what sort of gall it was?
I haven't been able to look it up. I've definitely seen similar ones before, but not red.
Red's
Normally they're sort of green.
Yeah, red's probably an anthocyanin, but it almost certainly is an insect gall. And so it'd be worthwhile cutting it apart.
Yep.
Be able to see what's there. The other thing that you can do is when you're looking to try and figure it out is look at for some of the older ones. If there are older galls, see if there are a cut exit hole. So exit holes where something has chewed its way out, they'll be perfectly round, or see whether the exit holes are in existence and formed here. If you can see small little holes, it may well be that it's a Hemiptera gall. The other ones are going to be wasp galls predominantly, but there are a couple of other things that form them. But it's certainly spectacular.
No, I should have taken a photo from further away too, because this is occurring throughout the whole tree.
Yeah,
It's not just a one-off. It's like everywhere.
Makes me think that it might be Hemiptera. Hemiptera have a lot of these. The female is wingless, so we say she's apterous, meaning not asexual, not sexual. Pteris with a P, as in pterodactyl, or the things that create wings. So apterous meaning without wings. So she's not able to fly. She's trapped in there. She's entombed in there. She's going to die. And so the young, called crawlers, are circulated by wind. They actually become airborne. They can take off and get picked up by the wind. They can be distributed quite some distance away. Pretty neat. I'd happily, if you put it in a sealed container, I'd happily have you send some to me and see if I can't help in identifying it. But that would be my first guess is Hemiptera gall. Could be a wasp gall. If it's a wasp gall, the wasp adult will come out. But I suggest Hemiptera just simply because it's so much of it, as you've described on one tree. And so when you don't get strong winds and you're wind-borne as an insect, the next choice is to pick the family home.
Yeah, you don't get very far.
Yeah. And so you tend to crawl to the next spot looking for the next flower and starting all over again. So that's what it looks like. It doesn't look like it's fungal. It does look like it's insect source. So neat. I've never seen it before. I think it looks fantastic. I'd love to have it on Acacia Baleana over here in Sydney, but I won't. Go to that. The reason for not doing that is sometimes these things in their home area are relatively well controlled, but we've had a number of diseases, native diseases, that have spread very rapidly after they've been taken out of their home domain. And a couple of that come to mind are Peropsides calypso, the lily-pilly leaf beetle. Really wasn't a problem until about 2010 or thereabouts. And somebody growing lily-pillies in the sort of area up behind Belgian, Coffs Harbour, somewhere like that, has had them lay in a tree above, pupate, chew the leaves to pieces, beetles come down, and eggs have been laid, and then it's just been spread everywhere. And it's in a matter of 2 years or 3 years, it was distributed right throughout the east coast of Australia. The next one that comes to mind is Thermostochorus peregrinus. We used to think it was Thermostochorus australis. It was discovered in North Ryde in about 1998, from my recollection, somewhere around then. A native insect, native Hemiptera, and it had reached plague proportions on a number of scoparias, and we didn't really know what to do about it. And nothing really known about the tree prior to that. Common name, winged bronzing bug. And then the next thing is we've got someone in South America saying, look, it's not australis. It is peregrinus, a new species completely, never described before. And that spread around the world within a matter of probably 5 to 6 years. Because there's a difference between having, 10 or 20 or 100 or 1,000 on a tree and having 1 million on a tree. As soon as the numbers start to get higher, the risk of it becoming an outbreak elsewhere also increases, exactly the same as our lily-pilly leaf beetle. So if you are handling stuff like this, the recommendation is, if you're sending it for identification, is to put it in a sealed container and advise the receiving party that it's coming and that it is in a sealed container just for biosecurity purposes. It's almost certainly native, but it may well be that it's normally kept under control by some other organism, another wasp or another insect of some description that isn't present wherever else Acacia baliana has been planted, and lots of places been planted, and all of a sudden you could it go to just ridiculous proportions in no time. So that's the recommendations we give you for handling things for identification. So yeah, I'd be curious to see a couple of them close up just to see what they are.
Might do some more digging on that one.
Could I ask, is it just as simple, if that's a specimen tree that the owner wants to keep and wants to get rid of the galls, as simple as pruning out the affected parts, bagging up and disposing of them?
Absolutely. There's a gall in Australia, citrus gall, created by the citrus gall wasp, and that's exactly the recommendation.
Yeah.
Prune it out. Good luck. But
Gets right into the wood.
Yeah, but the process is the same, and in that case it's a wasp, but an infected tree is often more vulnerable, and infections are fascinating things, as we've seen from COVID, for example, recently, where we see that it affects different people differently, it affects different plants differently, so some are more susceptible. If I wanted to grow this, there's a good chance that this parent tree as a host would be good to propagate off cuttings, because we already know that it's vulnerable. And what would be interesting to find out is whether other Acacia baliana in the area likewise have infections, or whether it's just the one tree. And slight changes in genetics, very slight changes in genetics, can have a huge impact. And we see that all the time with human beings. Probably not a good example, but an example of the same is peanut allergy. Slight little change in genetics, and all of a sudden, something that can kill you. And there are a whole pile of those sort of things that exist within a genome that we find difficult to deal with. And that's why when we're doing trials, almost no trial gives you 100% perfection. In fact, if you see 100% perfection in a trial, you almost got to ask who's dodging up the results. And so that's one of the things that scientists look for in terms of reliability. You've tested 1,000 things for something, and it's 100%. The question is, what's happening and why. So excellent set of photographs. Next one. Who's have we got here? David. David, are you online?
Hello, yes. How you going?
Okay. So here we've got a eucalypt that was kept, and a number of them nearby were removed, but this particular one has been retained, and all of a sudden we've got an error in the upper canopy that's starting to go off. Yep. Is that how I read it? And that's this portion here. And look, lots of variables. Okay, David, you're in Victoria?
That's correct, yeah, Mansfield.
Mansfield. You'll have to excuse my ignorance. That's not a suburb of Melbourne, or is it?
No, it's about 2.5 hours northeast of Melbourne, up near Lake Eildon, Wangaratta, Mount Buller.
Climatically, what's it like? Have you had droughts there like they've had in Melbourne, or?
No, we've had a lot of rain in the last 12 months. Been very wet.
A couple of things that could be. This process of foliage dying off and being retained is known as Marcescence. And so if it's not a Marcescent species, an oak is a Marcescent species, it it doesn't lose its leaves at autumn. It holds onto them. They look brown. They look dead. So Marcescence tells me that something's happened fairly rapidly. And the things that are likely to do that are root damage. And root damage could be biotic or abiotic. So we're talking about abiotic, poisoning, physical damage. So, you know, potentially maybe something like some large roots cut if they've put that driveway through more recently or put a service through. And
along the fence, this is a landscape supply yard leading into an earthworks company, and where that fence is there, pretty much along the fence line, they dug a trench to the front corner of that fence, and there's a washdown area. So yeah, they cut off a large portion of the roots on that would be the eastern side of the tree.
Okay, now there's a washdown area here, you're saying, that for washing down in this area? Yeah.
To the right, inside the fence line, there's you can sort of see a broom or something hanging on the fence.
Oh, yep.
Yeah, so just in there, inside there's a washdown area where they're washing down their tractors and loaders and trucks all the time.
Okay, so landscape supplies is not so worrisome, but landscape supplies and nursery stock can be. Nursery stock in particular is a really great way to spread Phytophthora cinnamomi. So there's a possibility again that there's Phytophthora, and Phytophthora does cause death of trees, and it's usually fairly rapid. Sometimes you'll get it thinning out and the tree fighting back. Some really vigorous trees don't care at all. So there are some possibilities. And investigation, you can go out and bait for Phytophthora or do an ELISA test for Phytophthora. Just because Phytophthora is there doesn't mean it's the cause. There's no evidence of lightning strike that I could see on it.
No.
Sometimes lightning strike is very bland and you almost see nothing, but you'll usually get some indicator like a burn off of the grass at the base or something like that. And it doesn't appear to be from what I have seen there. So the cut root is on the opposite side of where the damage is, or at least it appears to be. But that doesn't mean anything. And it's hard to know what this driving backwards and forwards and the driveway there has done. But I wouldn't expect it to do much, but create a bit of a drier patch underneath. The woody roots, you know, aren't absorbing water, it's just absorbing roots, and they'll grow where they're stimulated. So what would I do? Remove the dead portion. The tree's going to look fairly lopsided at that point in time, and it may be smart to look at, you know, a very light reduction pruning somewhere around about here, just to bring that height, that remaining section down a bit. Unfortunately, most pruning that gets done to trees is exactly the opposite of what we want to have done, and that's what they've done here. They've raised it up, and I don't know how we change that as a habit, but raising the canopy increases the negative impacts on the tree, increases risk. Reduction reduces risk. So, but reducing eucalypts is a hard process, particularly what I call fine reduction or little bits. You know, you need an elevated work platform or a crane and a guy working from a harness from the crane to really be able to deal with it.
Mark, would you look at trying to improve tree health before you did any pruning?
Yeah, look, I think if this continues to go off and turns brown, then I'd just prune that off in time. Typically, after a section's died, you get a reduced level of risk. That is, you've got no sail, so the boat's not going to get blown around. So that area will reduce in likelihood of anything failing. The dilemma with leaving it there longer term, of course, is that something will drop when you don't want it to. So, you know, probably, again, depending on the species, 5 years or so, you might want to think about planning to remove something that might be a problem in terms of dropping, likelihood of it harming someone almost going to be zero still. By almost zero, it's how many times do you think a vehicle is going to be underneath that portion of the tree, or a person? Pretty small number.
Quite frequently, in and out of the landscaping yard, and that road there, Dead Horse Lane, is in the industrial area, so it is quite busy. As a footnote too, council, part of the development, the driveway is supposed to be sealed with bitumen, and council are now asking them to seal the driveway around the tree with bitumen.
Yeah, nothing like it, is it? Just looking at the regularity and the frequency of use, and again, I'm only going to be able to take some guesses, but I'm guessing that it's not going to be used 24 hours a day. I'm guessing it's used 12 hours a day maximum, and most workplaces don't work that much, and the speed is going to be comparatively slow. So we're probably looking at 12, no more than 40 trees an hour. That's cars. That's a car every hour, minute and a half, or a truck every minute. That's fairly intensive. And in all of your shots, there's not a single car or a single truck. So I'm thinking that's probably a fairly, so if you're using QTR as target range 1, size of part, I don't know what it is, but it looks like about 260 mils, and it's going to take a long time for stuff of that size to fail. We're more likely to get stuff wrist size fail, so something 5 to 10 centimeters in diameter. So size part would be, in the next 12 months, would be 4, and then probability of failure, I don't know the species, but I'm pretty certain that it holds some dead wood rather than getting rid of it all the time. So maybe even a 2 or a 3. But if we say 2, because we're cautious, we've got 1 in 500,000 risk of harm. And at 1 in 500,000 risk of harm, it's already as low as reasonably practicable, because I guarantee it's going to cost you more than $10 to prune that off.
Yes.
But again, that doesn't mean that you don't go ahead and prune from a management perspective, just not from a risk perspective. We tell people there's no need to do it from a risk perspective at this stage, and certainly, David, you'd pick it up in 5 or 10 years' time if there's still big stuff there and starting to degrade. So I usually tell people best time not to let it go past is when it starts dropping stuff about the size of your wrist. That sort of getting close to the 100 mil stage, time to start thinking about getting rid of dead parts. But that can take decades. A whole pile of grey box that were killed by a grey box psyllid on the property next door, and there's still a whole pile of small branches less than wrist thickness up there that haven't fallen, and most trees are only just getting to that sort of size, and that's 10 years later, 12 years later. So it's a fair bit of time before action needs to be taken. And
What steps could you take to improve plant health, Mark?
It's really in a hard spot, isn't it? Literally. Mulch the area in here would be nice if that was doable. And that's only because, again, if we've got things like Phytophthora around, the fungi that help degrade mulch are antagonistic towards Phytophthora. So we create a better environment. We increase the likelihood of getting mycorrhizae in the ectomycorrhizae, and they're important. So mulch would probably be the most critical thing that we could do. David said that fairly good rainfall in the area, and if it's within the sort of range that's typical for this species and sort of close to the ideal or optimal range, then irrigation is not going to be much benefit. There might be a bit because we've lost, as I said, access to some of this area under here.
So do people still vertical mulch or radial mulch, or?
If I've got a choice, I'll mulch over the surface, not at depth. Mulching at depth does what nature tends not to do as frequently, and it comes with some risk. As you get deeper down, organic material wants to degrade anaerobically, and you get sulfur dioxide and methane produced. You get an oxidation reduction issue that's horrendous. So you end up with root systems that get killed. If I wanted to get something at depth, and if I wanted to play with this driveway, if David said, look, there's really, we need to get some water back in underneath that. Not that I'm saying that, but if you were of that opinion, if you could bitumize and then cut out with a cutter a hole that was maybe 150 or so, 200 mils deep, so you're below the bitumen and the compacted subbase, and then filled it with a porous material, black pebble and bonding agent, rubberized tar, whatever you wanted. You'd probably want to put a sleeve down for the first 100 mils or so, because you want it still the water to start below the depth. The whole thing of sealing is to stop water getting in. If it's concrete, I'd have no troubles. I'm always more concerned about bitumen. You know, not that bitumen's bad, but it's just so much easier to play and manipulate concrete because it is load bearing, whereas the whole purpose of bitumen is to exclude water getting into a compacted layer. So the thought is that concrete's a horrible material for trees. In fact, I would rather any day concrete, because I could, for a start, I could lift it up here and have a curve that was, you know, 150 up, and have it a void in behind here that I put mulch in, whereas I can't do that with bitumen. I've got to excavate and then compact. And then, as David says, now they're going to put hot top over the top of that. Or, yeah, probably also they might use spray bitumen on the two. And
Is
it looks
it Marcescence?
Yeah.
Yes, it is. Yep.
Yeah. And where's the nearest water source to the tree, David?
Yeah, just on the other side of the fence where that broom's hanging. And I don't know if you can see it, but there's a sign there to the right of the tree, now open. Just next to that, there's a sprinkler. So they've actually, this is about 18 months old now that this driveway has been done, but the first summer they actually irrigated it. You would come past and see the sprinkler operating in summer. So
Yeah.
they had been putting water on it, but they haven't had to since summer because it's just been so wet.
Yeah, look, I would be worried more than anything else about Phytophthora being a possibility. That would be my first gut level, but again, not at all proof positive, and we've got no basal lesions or nothing else that would allow us to go through the diagnostic process. If we do a bait and we find Phytophthora, it doesn't mean that it's the cause of the problem, any more than if you find my DNA at a crime scene. Doesn't necessarily mean that I'm the person that's killed the person. It just means I've been there.
Is Marcescence susceptible to Phytophthora?
Yeah. All trees. I mean, Phytophthora is a weak pathogen. It's not a strong pathogen, so it tends to be secondary. Some exceptions, for example, Xanthorrhoea grass trees. It's a primary pathogen. It'll kill almost certainly. So they're a great indicator plant. You know, as Marcescence is a riparian species, so you know, you would seem to think that it'd be reasonably resistant, but the evidence suggests that Phytophthora cinnamoma was introduced to Australia, not that it was endemic. So it's probably introduced with our earlier imports. We put material with soil, and it's spread around by bicycle tires, four-wheel drives, trucks, walking boots. Mark is down in Tasmania where there are whole pile areas that have got these Phytophthora washdown areas to reduce the likelihood of you spreading it. And it just takes, you know, a few spores on the bottom of your boot or on the tire of the bicycle to be spread around. So driveways are an area that are prone. So I think you've got a few things there that give me some confidence that would be where I'd start, first of all, but how I diagnose it, I have no idea. Because we haven't got a part down here that's dying. We've got a part up here that's dying, and we can't get to the root system. So we don't have access under the driveway. So I think Mick's comment in managing the health is the way to go forward.
Cool. Thanks.
No worries. David,
Yes,
you let me down. I was hoping to see some scar trees.
they are scar trees.
They're modern scar trees.
Yes.
Yeah. Rather than traditional. What's really interesting is how some of this has been done. So this is on a tree that's been lying down, and they've cut in and cut the bark out and then made these modern cuts. And what we're finding is these occlude faster than we thought they did. So this looks like a Marcescence again, is it?
That's correct. Yes.
Yeah. And again, looking at this, it's a tree that's fallen over and continue to grow. This might take 40 or 50 or 100 years to occlude, but in that sort of time frame, it'll be completely closed over. And that's really different than what we often portray with scar trees, the traditionally modified trees. The things that they're modified for, and this process of carving into them, I don't know, apart from the Murrumbidgee, there are a few nations that do carve, and then up through the Wiradjuri, and then I'm going to be wrong on the pronunciation, but I think it's the Gilmaroy nation above, they carve, but not all nations carve. And there's 200 and something other nations in Australia. So carving is a little unusual in practices. So most of the culturally modified trees are associated with functional use, so cutting something of purpose, so canoe, shield, two types of shield. Fighting and sparring shields are wood, they're solid, they're nasty, they're short, very narrow. And then the sort of bigger, more protective shield are less common. Bark is one material that's used, but frequently, again, they're wood. And then coulamons can be bark, but frequently were wood, because, again, durability. Doesn't take much of us in arboriculture to realize that bark is not a great material to be working with in terms of durability, whereas if you're talking about a thin-walled piece of wood, it's got great durability. So you make 10 out of bark or 1 out of wood. Wood's 3, 4, 5 times harder to work, but great durability. It doesn't take much common sense to realize that bark is a very shortcut way of doing things that you wouldn't do for something that you wanted to have longer term. And so coulamons are a long-term possession. You want it for holding the baby when they're younger, for carrying food, for carrying all sorts of things. So it's something you're going to have for a large portion of your life. So they weren't often this sort of size, and they would occlude a matter of 30 or 40 years. Canoe trees, there are a number of them around, but not that many. Most trees that are called canoe trees are simply trees with long scars on them. And I hate to say it, but, once they're more than 500 meters to a kilometer from a water source, you've got to have some questions about your attitude towards the thinking capacity of the average Indigenous Australian. They're a lot smarter than wanting to carry something that weighs 30 kilograms, 2 guys ideally to carry it, when you can cut it just right beside the bank of the river, particularly prior to white invasion, where Marcescence was almost certainly growing on 90% of our riverine areas. So perfect choice and nicely done. The other thing that's interesting about canoe trees is that there are 2 sorts of canoes. Those that are shaped usually from a bent. So if we had a trunk that was bent like this, you've got some dishing already, they make ideal canoe trees. Straight ones less ideal, because you've got to have some curvature at the ends to get the thing to float. If it's just dead flat, you're not going to have it float, it's going to sink. So then you've got to start shaping it if you're doing that, and that's quite hard to do. So the other sort of bark canoes, which you get, for example, on the east coast of Australia were wrap canoes, and they would take the bark, invert it, and then tie the two ends together. And by doing that, you get something that's more like a traditional canoe. And there's a great website on the Maritime Museum that shows you the two different primary types. Again, those that are shaped from a tree that's got a slight bend in it, and that are more sort of traditionally canoe shaped, tend to be on rivers and rivers only, and for good reason. They're not got high enough sides to be suitable for anything that's got any sort of chop on it. You start getting, coastal areas, you put it out at Manly, you'll get it out and it'll sink. The first wave will take it down. So again, that's just useful to think about. But are these important? The answer is yes, they're important. They're important for several reasons. One is they give us information about how trees grow and what they're doing in response to cultural modification, regardless of their timing. And it also starts to give back to the culture. There's been some wonderful stuff recently on canoe making going on with a number of the nations going back and trying to relearn those primitive skills. So I think
that's what this guy's doing, this Mick Harding. If you look up, just do a search, We Scar Many Trees, he's actually using his sons. So I suppose he's teaching them the tradition, but this was more for art on the Great Victorian Rail Trail. And when you look at the site, he's probably done about 18 or 20 trees in total. But just one interesting little paragraph here says, along the length of the Great Victorian Rail Trail, we've removed the bark from healthy eucalypts and then carved a message in the sapwood.
Yeah, I'd be interested to know whether the formation of dendroglyphs or carving into the wood patterns was a tradition that went on that far down. I haven't spent that much time looking at it. I did. So my wife's Wiradjuri. So my family, my kids are Wiradjuri. And so I looked at it from their point of view to see how much influence that had had on surrounding nations. And, there's lots of places like Sydney where the Dargs did no, or there's no evidence they did any carving of the trunk itself. There was just utilization of material. And again, there are things that are going to change from nation to nation. They're not consistent. You think they might be, but Dargs, for example, are all wrap canoes. There's no evidence of anything else but a wrap canoe. Wrap canoe, take the bark all the way off around the tree, kills the tree. And, very different in its process than these yuki type canoes. That's a little bit longer than that, and you'd get a canoe out of that. Looking at, I'm guessing again, David, looks probably 600 to 800 across here.
Yeah, it'd be about that.
Yeah. So 50% longer, and you'd get a canoe that would support a person of 45, 50 kilos. And again, you've got to remember that a lot of the Indigenous Australians weren't very big people. They weren't huge. They didn't go to McDonald's. They didn't have problems like I have with obesity. They managed to stay fairly lean and fairly keen. Otherwise, they were going to have problems. So, yeah, it's excellent. It's great to see. And, I think bringing those sort of practices back into the culture of the communities is really important. The one big issue I have is probably 3 out of 4 trees that are described as scar trees or culturally modified trees aren't. 3 out of 4 are just trees that have got a scar, and therefore it's concluded that they're a scar tree. And there's one not too far from me that's been described as a possible scar tree on a Eucalyptus teraticornis that's probably only 50 years old. I'm pretty certain that that's not a scar tree, given that Indigenous occupation stopped 200 years ago in the area. Pretty unlikely that it's a traditional culturally modified tree. It could be something that somebody has done, although this process recently of trying to come back and re-hone these skills is probably only 30, 40 years old, something like that. It really is quite recent. There's a great one down in Albury, the goanna tree, and I know it was published in the Bark and then in anthropology publication, a paper by the name of The Disappearing Goanna. We looked at it when I did my paper in Queensland for ARBOS, and by that stage, the wound had pretty well completely occluded. So it was about 36, 37 years and completely covered. So, yeah, great. Well, a couple of things. First of all, a guy called Simon Strauss, he works with Active, sent me an email the other day and he said he finally found tips and he thought it was great and war. And he made the comment, and I'd like to get the feedback on you. He made the comment, hopefully you're going to go through all the material in each unit that's relevant to it and make sure that we've covered every component of the curriculum when you're talking, just so that it can be used as a resource later on. What are your thoughts about that, people? Any thoughts?
Well, I would say what curriculum to start with. I mean, these sessions aren't designed to study a particular curriculum or any particular aspect. It's more of what we find interesting, and we invite people to ask questions that interest them. And we tend to discuss subjects that are interesting to people because these are the things that again and again people want to know. So, for example, Mick was asking about the insurance. We have spoken about that before, but it's on people's minds. So that's the sort of thing that we need to talk about. We're not here to provide an education resource specifically in that way.
Yeah, no, I get that. But when we've got those little dead patches, Peter, and we do have them, and we'll maybe get more of them in time, do we look at why is it important to identify the species and determine the region of origin and seasonal growth characteristics? That's one of the performance criteria from the unit diagnosed tree disease. And that's all I was saying. I'm happy to start looking, if we've got some quiet time, to, take an element or two and talk about them. Some of them you're going to say, well, I know that already. But
I think these are excellent prompts for, as you say, filling in quiet times. And there's no reason why we couldn't use some of these units to look for things that are of interest.
So guys, any other thoughts? I've got Peter's, mine, Simon Strauss's. I'm looking to you. This is produced for you, not for me.
Mark, I'm currently a student of Cert 5. I'm nearly finished, a couple of months away. And I've found these really, really good. Everything that we talk about just enhances what I'm learning at the moment. And every single one I've been a part of has been really good. So if we were to take it to the next level and start looking at some of the subjects, I think it would be a good thing.
Okay.
I don't see it as a negative. I think they're great resources. Like you say, so some things you'd know, some things you wouldn't, but throw it out there and I think you'd get a few bites.
Yeah, okay, great. Any other thoughts from anyone?
Yeah, I think it's a good idea. I think, as you said, use some of the elements as a prompt for a discussion. I think that's good.
Yep. Okay, great. So it's not necessarily going through it as the whole, we're going to do this today, but so identify tree species and determine the region of origin and seasonal growth characteristics is important. It's important because we want to know, Ficus microcarpa hillii comes from northern Queensland, where it's high rainfall, 1,800 mils plus a year. It's a species that if I was looking at trying to manipulate in the landscape, I'd probably give a lot more water to than something else. Camaldulensis, it's a riverine or riparian species often associated with groundwater. It's got massively deep sinker roots. I don't know whether any of you have seen them when they're eroded away. Amazing root systems in terms of going downwards as well. So again, it helps give us information about our plants and understanding how to care for them. So that would be a sort of an example. So that's great. Okay, well, I've got a few others that I'm going to go over in terms of photographs, and then I'm going to go. You might notice I'm sounding a little stuffy. I've got good computer virus software, so you won't get anything. You don't have to worry about that. But I think I might have a bit of a virus. I will do a test later on to find out. But I thought I'd share with you again some photographs from my last month, just so you get an idea. And this was one that just not the best shot. I apologize. But hopefully you can see a wasp and a Lepidoptera larvae caterpillar. And this is on a casuarina. And I was just standing outside and there it was. And we haven't talked about much, but there are a whole pile of beneficial relationships. Can you see the wasp? There's a paper wasp. So this is a good guy. Don't have to worry about him. But a lot of our wasps are predatory. And by predatory, we mean they're going to kill their host. And there's two words that we think of when it comes to this behavior, maybe three. Things that eat it now. So a bird, for example, will go through and eat that caterpillar and it's just gone. It's predating on them. Then with things like our secondary diseases or the disease of the caterpillar, here you've got a wasp and the wasp is being predatory. And that wasp isn't going to kill it. That wasp is going to stun that caterpillar, put it into a casing, and then let its eggs or an egg grow inside it. And these are called parasitoid wasps. Parasitoid is a wasp that, or is an insect or an organism. It could be a fly, it could be nematodes, for example, spiders, a number of things fit in that category. Parasitoid simply means it's going to take over that host and eat it slowly. So it stays alive, kept stunned or kept immobile, and then they'll slowly eat it. And at their exit, the adult is, the host is dead. So the host dies. Whereas a parasite is something that lives on us. So for example, worms, threadworms and people, they live on us, but they're not going to kill us. So there's a difference between a parasite and a parasitoid. Parasites affect the health, but they don't kill. Parasitoids kill. So hopefully that's worthwhile adding those two little words to your vocabulary. Here's one that I observed down the road, and I was with somebody a lot younger than me who thought that it was amazing to find these things. Does anyone know what these are?
Ladybugs.
Ladybug what?
Larvae.
Larvae, yeah. Larvae. Here it's pupating or getting ready to pupate. And what's interesting about this one is it's got no dots. Anyone want to guess why?
To the female.
No, good guess though. No, it's just emerged. And so it's got no pigmenting to it at all. Coloration can take a few days to come out. So if you see a beetle that's just come out of pupation, just wait a little bit, get it out in the sun, let it start producing coloration. Often the colorings relate to melanin, and so you get browns and blacks coming out. So that's all that's going to happen in this case. It is indeed a predatory ladybird. So over time, these black dots will develop. But when it first comes out, it's all yellow. Isn't that neat? I think that's great. So yeah, my second oldest granddaughter was down there and she just thought it was brilliant. And I'll tell you that from an arborist point of view is if you're out doing a consultation with a client and they've got a child, finding things that help the child interact and relate to the tree and appreciate the trees is a great way of helping them love and appreciate trees and transferring that often back to parents and grandparents. It's amazing how manipulative little kids are. So that's something to keep in mind. Ladybirds, rounded shape, they're very similar in some ways to a number of other beetles, particularly our leaf-eating beetles, but they've got clubbed antennae, so there's a slight bump at the end I don't think that's a particularly great shot, but that does help describe the difference there. Oops, come on, work. It's not working. I have to go down the side, move you guys to one side. When I move that bar, is that bar on the screen for you? No, okay.
No.
Ah, I know why that's saying it says that's Hellenberg. I don't want Helensburgh. I want photos. Next one, you get, oh no, here, one of that. This is the egg of the ladybird, laid in clusters. The egg shape and the pattern is often indicative of what we've got. So worthwhile starting to learn the differences in the egg shape and configuration of a number of things. Propsis, for example, the leaf beetles or eucalypts, lay them in a rosette around the stem as one of the laying patterns. So getting used to that is important. This is on a pinus. Can you see all the little white dots on that?
Mm-hmm.
Yep. Does anyone want to know, or anyone want to guess what that is?
Not stomates at all.
Who asked that?
David.
David, perfect. Absolutely brilliant. Yeah, there's stomata. I would never have guessed it, except I know it. But yeah, so one of the things that we look at with gymnosperms is the patterning of the stomata is one of those things that help us identify. And so again, it's easy enough to have someone say, I'm concerned about the lichen on the tree. They'll never say lichen. I'm concerned about the fungus growing on the tree. No, leave the fungus alone. And fungus is difficult. Here we've got a cypress or a Capresso cypirus or whatever it is today. Those of you who don't know, American cypress and European cypress have been split apart, and those American cypress are now Hespocypirus. Just one of those changes. But this little thing here, this little conical lump here is called a pycnidia, and this little leaf scale here is being affected by a fungus. You can see it damaging the cells. And so again, got a lot of things that exist in that way. And the only way we can identify these is DNA or culturing. And we don't have a lot of information on either. So we look at symptomatics instead. So my nice, easy, lazy way of dealing with these is to say, we've got a micro fungi. That means a fungi with a fruiting body that doesn't allow us to give any taxonomical description. You can pick the difference between a normal field mushroom, for example, and Amanita phallus, the death cap fungi. And you've probably heard in the last month or so about the young lady who entertained her in-laws and inadvertently gave them death cap fungi and killed 3 of the people. And she mysteriously didn't have any herself. You know,
I think she said she did, but she didn't eat a lot, and she said she was sick. So whether or not she was telling the truth, but it is a bit sus that it was the in-laws that got sick, I think.
Yeah, and she would have been better to have a sublethal dose and get taken to the hospital. So Andrew, if you're thinking about doing it, keep that in mind. You know, 1 death cap fungi won't kill you. 3 or 4 is pretty well guaranteed to. Again, this issue of dose starts to become critical with lots of things. This is another microfungi, and these little rounded lumpy areas are often referred to as a curvula if they split open and spread spores, and that's almost certainly what they are. So the fungus is going through using enzymes to degrade the tissue and making these nice big rounded lumps. So pycnidia and curvulas are 2 fruiting bodies that help us describe what we've got, and that at least breaks down our fungus a little bit further. But beyond that, it's pretty difficult to come up with anything that's positive. Now, why don't we do more material? Why don't we have more DNA? Why don't we have more tests? And the answer is plants don't matter. It's as simple as that. The cost of developing this sort of stuff is really expensive. So unless it's a major problem, you tend not to see anything. You will notice, if you look very carefully, there's a couple of cottony threads, again suggests that there might be some mites around. Mites, does anyone know how a mite feeds?
They have a rasping mouth part that damages the dermis of the plant, and then they just suck up the moisture.
Absolutely, David. They have a mouth part that rasps or cuts through, tears through the surface tissue of the cell and allows them to take cytosol, the inside out. And as a result, they often spread secondary things like fungi and viruses to the tree. So again, Hemiptera, Thysanoptera, and mites are things that help spread these fungi around. And so one of the things you can look for is, have I got something that fits in that group that's going to be causing some problems? And most of these shots that you're seeing now of here, you probably didn't see it because it's really badly concealed. There is a mite there. It's a funny little yellowy thing with some legs on it, only just, and it's moving. My history of spotting mites is, if I sit and look at that under the microscope on the screen, I won't see mites. If I sit there and watch it for a couple of minutes, I often then do see the mites. That is, they're moving around. It's the movement that brings them to your attention. And I'm amazed at how many times you don't see them. So mites are a common problem in plant material. Sorry, busy month of catching up on some filing. This is one that some of you might be able to give me some feedback on. My guess is this is Platypus australis. Don't ask me why you'd give a genus and call it platypus, but it is. And it's a problem on Pittosporum undulatum. Who has Pittosporum undulatum endemic to their area? Andrew, Rob?
Yep.
Doesn't go down as far as Tasmania. Be thankful. It's a plant you'll often see very small holes, and this is a weevil. Unusual because it's got this massive big clubbed antennae, this geniculate. Again, geniculate means bent. Think of genuflexing, you're bending and you're bowing, so bending of the knee. This has got a small bent clubbed antennae, and these make a hole about 2 millimeters in diameter. And then that group of weevils we call bastricid. And bastricid carry around and spread fungi. Remember, cellulose is not readily digestible by animals. So things that are chewing on the wood have to have some way of dealing with things. They've either get enough starch out of the wood and they can digest the starch, or they've got to find some secondary way of dealing with it. So, for example, termites have a bacteria in their digestive system that helps them break it down. And that same principle goes all the way up to us as people, to cows. Cows have a digestive system, a rumen that allows them to regurgitate and break things down. Possums, for example, brush-tailed possums eat their own crap. They're what we call coprophagic. Don't use that word with a police officer. It's not meant to, but coprophagic means eat crap. There's another way of saying that that's a little less refined. And that, again, helps them to have this process of having bacteria on it that helps them make it accessible. So these little creatures kill trees, and I've seen them in Pittosporum undulatum now on half a dozen occasions over about the last 20 years, where lots of little holes and the tree's on its way out. You know it's going to die. So I'd be interested in if you see it at all. How do you find these things? You have to start removing the bark. And you realize fairly quickly as you start to remove the bark that the tree's well and truly on its way out. Peter, you and I did one like this on a leopard wood, I think it was, at Wallingbar.
That's right, yeah.
So, yeah, difficult. My gut level feeling is that it's not a primary problem. because I haven't seen it that frequently, my gut level feeling is it's picking on trees that it picks up are on the way out. And we've seen that with lots of things that we have as diseases. For example, jewel beetle, the most common one that affects eucalypts, attacks the eucalypt when it's on its way out, when it's stressed. New Zealand Christmas bush is not so well adapted to deal with it. And so it does it when it's only lightly stressed, and you'll see it come in and take out what are otherwise reasonably healthy looking New Zealand Christmas bush. And that's that issue again of how minor changes in genetics can result in a significant change in the way that the disease and the organism interact. So hopefully that's worthwhile seeing that.
Mark, what was the species name for that? Sorry, Platypus
Australis.
Australis, thank you.
That's probably my better of all the shots. But, you know, getting a good shot of these sort of things is difficult. Yeah, they're all taken with an Olympus TG. With a digital microscope. Again, not perfectly in focus, but enough that we can start picking things. That's one of those little volcanoes. The volcanoes, if you remember, are called pycnidia. And fungi tends to form barriers and then break the barriers, and form barriers and break the barriers. And you recognize that if you just look at the way that mold grows on your bread. Okay? So, whereas viruses tend to be controlled very strictly to venation. And there's a reason for that. There's really a fascinating reason. I'll explain that and then I'll call it quits for the day. The way they control, the way the virus is controlled, the virus is not living. So it needs to trick the cell to do things. It needs to send code to the computer control room, the nucleus. It says, produce a protein that tells the plasmodesmata, the little holes that connect one living cell with another, tell it to open the callose gateway and let me through. So there's a tiny little microscopic tube that's regulated, it's controlled, it opens and closes. So it's an aperture, not so much a plug. And so eventually, when it's done that a few times, the plant picks up that it's under attack. When we don't see plants as clever, and they're not in the way that we are, but they pick up that they're being attacked. And then they do a thing called programmed cell death, PCD, they kill off the adjacent cells. When the cell's dead, it can't produce a transport protein, so it can't infect the neighboring cell. So the veins are a really good spot for that to occur on, because it allows it to be regulated quite easily at that point. And so we see that as a fairly simple, but it really is quite marvelous. If your computer gets a virus or an infection, someone hacks into it, the first thing you need to do is disconnect from the system, isolate it. So you pull out your modem or turn off your Wi-Fi. Then if you need to, turn off your computer. But ideally, once you've disconnected it from your network, you're ready to start working on it. And that's all that the plant is doing. It's disconnecting from the network, saying, let's isolate these cells here. And the way to do that, I'm just going to get these 10 cells in this little area to die off. If they're dead, they can't communicate. The switch is off, the power switch. And I think that's a pretty neat way of controlling viruses. So plants do get viruses. Most of them aren't problematic. Most of them are relatively well controlled. Fungi are the big nemesis of plants. And it's interesting, fungi are not the big nemesis of people. There are very few fungi that are problematic for people. On the other hand, viruses are very problematic. So again, let's just see how different organisms deal with things differently. Those of you who have given it some thought, the human being has got almost as much foreign DNA in it as it's got normal DNA. So in your digestive system, on your skin, hate to tell you, those of you who don't know it, your eyelashes, for example, for most of you will have mites living in the base of them. They're beneficial. Don't panic. You start thinking about all the things that you've got in your body. You're not digesting food correctly without microflora, because you and I can't digest cellulose, okay? But there are a whole lot of other organisms that can. And those of you who don't understand the process of digesting cellulose as a human being, all you've got to do is think about baked beans, and you'll realize that, it's a fermentation and a breakdown process, not a straight absorption process. Why? There's side products produced, predominantly methane again. Plant cell walls are largely cellulose when they're not woody, and those cellulose of banana is largely plant cell wall. They're the things that got fiber in it. So when we talk about fiber, we are talking about plant cell walls. When they start talking about 30 grams of fiber, that's, sorry to the pun, but that's crap loads of cell walls, okay? And ideally, we should be doing our 30 grams of fiber, and so we end up eating lots of plant material. Without it, we've got problems. Thank goodness for plants, hey? Any questions before I go?
I just wanted to ask, what was Simon asking? Was he asking us to make these sessions more structured?
No, he's just asking whether we'd go through in time all the elements of the unit, so that people had a resource to go to that covered things. And if it's something that we do, and it seems like something we'll do, maybe Peter might just put a tag on it to say includes discussion on performance criteria, blah blah blah, or knowledge material, blah blah blah. If we get to being more formalized, just to assist. And a part of the problem, and I could be wrong, and I'm happy to be chided for it, I often think that my level of understanding of tree diseases is really rudimentary, and I'm guessing that my knowledge is better than a reasonable proportion of a arboricultural community. And so depending on the level of the instructor, you may or may not get exposed to a whole pile of material that might be beneficial. And there's, ideally, if we were to do half the units in a really wonderful way, most of our studies would have specialists come in. We'd have a mycologist come in, Peter, for what? You reckon 10 hours of instruction at least in mycology?
Yeah, I think that if we were to try and do more formal, more structured, more fitting a particular curriculum, then we'd certainly have to look at including input from people who know more than we do. And we have been able to do that a few times in the past. So we had somebody who knows a lot about the law come and talk to us about that. And we had a botanist come and talk to us. So we do that a little, but we certainly haven't concentrated on structuring these sessions in that way.
Yeah, and I don't want to structure it in that way, but maybe we might just look at adding a performance element if the number of questions is low. I
think the idea of getting prompts from those from those curriculums is a great idea, because they're interesting things, and as we fill out the gaps, then it becomes more of a useful resource.
Yeah, and look, we had one today just by looking at Eucalyptus verminalis and realizing that there are multiple subspecies, and eucalypts are a horrible genus to identify in the first place. They're up there with pigs, things that are horrible to play with.
I certainly have thought about trying to label these sessions so that it's easier for people to look for various subjects. But there's a couple of problems. Firstly, I'm basically lazy, and secondly, one of the things that works and that I like about the way you present these sessions is that you jump around and just follow a thread down a rabbit hole and then go and talk about something entirely different, and that's what makes it interesting. It's certainly quite different from a formal sort of teaching a classroom lecture where you've got a subject and you pursue that, and so there's benefits to doing it the way we do, and there's some drawbacks. So it's just the way it is.
Yeah, I'll never stop going down the rabbit holes. They're too much fun to
Right.
not do things. So they'll definitely stay. But I'll see what I can do about looking at little components to just throw in. And if I do that, then I'll point out where it is in terms of a PC or a knowledge component. Well, probably not the knowledge, because the knowledge component's right through the entire thing. That's really a primary underlying component. And yeah, look, it'd be great if we could get the occasional expert in other areas to come in and just have some time. So Peter, we might brainstorm on a few more of those. And
yeah,
right,
it's always been interesting when we have had people with specialized knowledge. So
on that question, and before I switch off in 3 minutes, is there any area that you guys would like to get someone with a lot more authority and knowledge in on, that we can start doing a hunt round a canvas?
Yeah, fungi, the mycology.
Oh, yeah, fungi.
Yep. Peter, what have we done in mycology to date? Have we done much?
Well, we did talk about Phytophthora, but certainly we have had other sessions where we've looked at various fungi, particularly the pathogenic and mildly pathogenic fungi. I think we've.
Have I done a PowerPoint presentation on fungi?
I think so. No, that would be interesting.
Okay, I do have one written already that covers the sort of bigger, more common ones. I updated it recently to include a couple of new changes that have occurred.
I think it's interesting to look at that sort of stuff in that structured way, because then when you're faced with a mushroom, you've got somewhere to start, some process to try and narrow it down.
Yeah, okay. Well, I also have one on microfungi, which, you're looking at some of those bits and pieces today. And I just hate microfungi with a vengeance, because I get to a point where I say it's probably an ascomycete, or it's probably a basidiomycete, but mostly an ascomycete. And that's it. And, the annoying thing is when I send stuff off to the plant diagnostic unit, or, somebody else does, and it comes back, it's got an ascomycete. Well, yeah, great. But all that, the answer is no. And that's, again, we've just got so much out there that we don't know.
The trouble is there's so many of them that not all of them have been described. So
most haven't. And then there's all this weird stuff. If you're old like me, there used to be fungi used to be a part of the plant kingdom. Is now separated out, and then now we're separated out of the fungi kingdom. A whole pile of others, at least two others, slime molds and the water molds have been separated out into their own kingdoms. It wasn't that long ago there was only two kingdoms. Pete, Vicky, and I all know that. Rob was around before the two kingdoms. He was around before Linnaeus. So we see these changes, and it's fascinating, but also very challenging. And then we get things that exist in different forms, and that's when it really gets complex. So we've got a whole pile of fungi that have got two names, and sometimes we don't know they've got two names. When they have two names and we know that they've got two names, there is a convention for determining which one to call it. But some of these fungi are different depending on the host they're on, for example. So I just say, look, you've got a microfungi, improve the health of the tree, manage the disease, things that go with it. So change the environment. Environment's one of the things in the disease triangle we can manipulate reasonably easily, and good luck. Because there are a whole pile of things. So, for example, one that we deal with, Fusarium oxysporum, former species Canariensis, the one that's attacking Phoenix canariensis. If you're in Melbourne, they're now saying we've got a different isolate of Fusarium oxysporum that's affecting Phoenix canariensis in Melbourne, and they're suggesting that the genetics tends to suggest that it evolved on its own in Victoria. Whether that's the case or not, good luck in ever knowing. But that's what it suggests. You know, the only reason we know it's Fusarium oxysporum is because of the way it looks. It's symptomatic and it's a major disease. It's a primary pathogen. It was a secondary pathogen. We wouldn't know anything because nobody would have paid any attention. You know, at the stage that we identified Fusarium oxysporum on Phoenix's, Brett Summerall was the head of the International Committee for Fusarium. Brett's an Australian mycologist, and I always find it interesting that experts in a particular area find the disease in their country. And a part of that is because a lot of these diseases are ubiquitous. They're all over the place. So, yeah, look, I think we can do some bits and pieces. I can give you an introduction, and then we can find some specialists to give you really in-depth areas, or for you to ask those horrible curly questions that I hate people asking, and you can destroy them instead of destroying me. So at that, I'll say good night to you all. Thanks for being here, and I'll see you who are attending WAL next Monday. Otherwise, I'll see the rest of you in a month's time.